Okay, in the last video, there's something I forgot to mention, or the video rather was cut short. But what I wanted to say is that fiber internet or fiber optic internet is quite expensive to install, and the other thing is that it has basically limited coverage in some rural areas, and there are different types of fiber connections. You have fiber to the home, fiber to the premises, fiber to the building, as well as you know fiber to the curb. The curb is the roadside station or the cabinet that you find on the street, right? So fiber is actually a broadband technology which is currently the fastest broadband technology, and the billions being invested in fiber optic internet. And so, by that, it is the most future-proof broadband technology because of that. Now, this video is on satellite internet as well as mobile broadband like your 3G, 4G, 5G, as well as fixed wireless internet access. So I'm gonna start with I'll dive right away into satellite internet. Now, this type of broadband technology, since I'm explaining broadband technologies, this broadband technologies delivers or broadband in terms of or through communication satellites which are orbiting the Earth. So how internet or satellite internet works is that the user usually sends data through a satellite dish. So, uh, billions of satellite or dish satellites around the world. So the user transmits data from the satellite dish, and then that signal travels to a satellite which is in orbit, orbiting the Earth or the Earth's atmosphere, right? And that communication satellite which receives the signal then relays that signal to a ground station, right? So that data is essentially connected to the internet backbone or the core internet service providers, or the first tier internet service providers, right? So what you usually find with satellite internet is that there are two main types of these types of satellite internet. One, you have geostationary satellites, and those are usually in your higher orbit, uh, and it's usually a distance of around 35,786 kilometers away from the Earth. Those are geostationary satellites. And then you have LEO satellites, or low Earth orbit satellites. And one classic or a modern example rather is Starlink. Starlink is a LEO satellite. It's closer to the Earth, right? So you have satellites which are further away up from the Earth, like 35,000 kilometers, approximately 35,000 kilometers away from the Earth. And then you have ones which are closer to the ground, like Starlink, right? So those ones are usually referred to as LEO or low Earth orbit satellite. So those are the two main types of satellite internet, two types of satellites that we'll be looking at in the near future, right? So these satellites, communication satellites, they have speeds that range, or bit rates that range between 10 megabits per second to more than 250 megabits per second. That's the typical speed. But Starlink can exceed these types of speed range, right? And satellite internet has certain advantages which other broadband technologies do not have, right? And one particular example is that satellite internet usually covers remote or rural areas. As I've said in the previous video, that fiber optic, or at the start of this video rather, I've said that fiber optic internet does not cover those rural areas. But on the other hand, satellite internet actually does that coverage for those regions or which do not have internet access. And the other thing about satellite internet is that it doesn't require any the so-called terrestrial infrastructure. As a user, you don't need to set up complicated infrastructure. I just use the broadband technology as it is. You buy usually you buy data caps or data from your service provider. That's how it works. But it has certain limitations, which include interference from the weather, also known as a rain fade, right? And the higher cost because you get data caps in some plans from your service provider. So those the data that you purchase from your service provider gets depleted. So those data caps are another limitation of this type of technology. So the more you buy these data plans, or yes, you buy these data plans, the higher the cost. So it's quite expensive in that regard, right? But satellite internet is essentially ideal for areas that do not have cable, that do not have DSL internet, or do not have fiber at all, right? And then there's more broadband or mobile broadband technologies like your 3G, your 4G, and your 5G. That's your third generation, the fourth generation, and the fifth generation of mobile broadband. So the way that it delivers broadband is that uh, 5G or 4G or 3G, they all use like cellular networks. I'm in South Africa, and the cellular networks that we commonly use, Telkom, Vodacom, MTN. Those are the prime ones, right? So mobile broadband, whether it's 4G or 5G or 3G, they use these cellular networks to provide internet access through your smartphone, through mobile hotspots, and even through routers as well. So how mobile broadband actually works is that it uses radio waves. It doesn't use any cables, but it uses radio waves. Those radio waves are transmitted between your mobile device or your smartphone, which has it has a SIM card, and it's transmitted between the base station from your service provider, or that base station is also known as a cell tower. So you have your mobile device, which is a SIM card, and you have radio waves which are transmitted in between, your mobile device and the cell tower, right? And as well as what do you call this? The core network, which is connected to the internet backbone. The core network would be your main internet service provider, or usually a second tier service provider. As I've mentioned, that in South Africa we have Telkom, we have MTN, we have Vodacom as well. So that's the core network that I'm talking about, which is connected to the internet backbone. That's the first tier internet service provider who own the infrastructure around the world for internet, right? So that's how mobile broadband technologies work, right? And these you have several generations from of these mobile broadband, as I've mentioned. You have your 3G, your 4G, and then this fifth generation. With 3G, you have speeds that typically range up to 2 megabits per second, whereas 4G had speeds which are actually higher, right? From tens of megabits per second all the way to like hundreds or hundreds of Mbps, right? Then you had 5G, the fifth generation of mobile broadband, which had significantly higher speeds, hundreds of megabits per second to several gigabits per second, or Gbps, right? Um, Now, your 3G basically allowed you to do basic web browsing. Email systems worked uh, with 3G, but it had limitations, which the fourth generation of 4G LTE covered, right? And which included efficient HD streaming or 4K video streaming, including video calls or video conferencing. Then you had 5G. 5G, had ultra low, or has rather, because it's the most current one. 6G is on the way, but uh, 5G is what we have right now. So it has ultra low latency, and that's the superpower of 5G. And it also supports various technologies like your smart TVs, no, your smart cities, your IoT devices. It does also work hand in hand with autonomous vehicles around the world, right? So those are all the generation of mobile broadband, right? And so mobile broadband, as all these generations that I've mentioned, they have several, advantages or key strengths, right? And the most obvious one is the mobility um, advantage, right? So because you can access this type of broadband anywhere. Understand, it's not fixed to a specific location. You can access it anywhere, and it's easy to use. Quick deployment. There's no fastness. It's hassle free, right? And another strength of mobile broadband is that you don't need any physical cables because obviously, as I've said, that it uses radio waves which are transmitted between your mobile device and that base tower, the cell tower, and the core network or internet service provider, right? So you don't need any physical cables. Um, just need radio waves, right? But obviously, it has limitations, and those limitations include things like the signal strength of. You realize that signal strength actually varies by location, so it's not the same um, um, everywhere you move or when you change location. Signal strength is not always the same. That's the a limitation of mobile broadband, all these generations, and as well as data caps. I've spoken about data caps when I've talked about satellite internet. Those data caps also apply, right? So that's mobile broadband, and 5G actually represents a major advancement because it gives us ultra low latency, which means there's less delay in communication, and as well as high capacity, right? And another major issue with mobile broadband is the issue of network congestion. The network becomes congested between or usually around peak usage times, right? So 5G actually represents high capacity as well as that ultra low latency. Now, the last broadband technology or class of broadband technology is fixed wireless access or FWA, which gives you or provides broadband using it provides broadband to a fixed location. It's not mobile like your 5G, your 4G, and so on. It provides broadband to a specific fixed location using radio waves. It doesn't use any physical cable, right? So how it works, again, you have this wireless transmitter or the tower that sends signals, and then you have, as the user of that internet or that technology, you would install a receiver antenna. That receiver antenna is installed in your premises, right? And then there is what do you call this? um I forgot what it's called, but then I'll remember it as I go along. But then there is or FWA actually uses microwave links as well, and the 4G, the 5G infrastructure. So it's compatible with 4G, and it's compatible with mobile broadband, right? Because it uses 4G and 5G infrastructure as well as systems which are called point-to-point systems or communication systems or point to multi-point communication systems. So it uses those systems, right? And then you have speeds that range typically from uh, somewhere around tens of megabits per second or 10 mbps to 1 gigabits per second. um, but it depends on the technology, on the type of FWA which you're using, right? It depends entirely on that. Then it has several strengths or advantages, right? And one advantage of this broadband technology is that it actually, or it's suitable or ideal for rural, if I can't say this word properly, rural or underserved areas, right? um, so it's ideal for those areas, right? And you don't need any underground cables, so because it uses radio waves similar to mobile broadband, but obviously there are limitations uh, of FWA, such as the users have to share the bandwidth, and you also have what do you call this? weather or physical obstacles which can affect the signal, right? So those are some of the limitations of FWA or fixed wireless internet access. But just so you know, FWA is increasingly used with 5G. As I've said, it's compatible with all broadband technologies. So it's increasingly used with your 5G, to in order to provide high speed internet, home internet, right? So I'm gonna stop it there, and in the next video, and there I'm gonna proceed or dive into the internet architecture. More specifically, I'm going to look at the internet service providers. Who are they and what they do? What's their role? See you there.